And now we're going to have just a look at declarative programming or logic programming, which is a really, really neat idea in which you don't have to write a computer program at all. There's no sequence of steps. You're not telling the computer, do this, then do this, and what's the value of this. Instead, you just tell it things you know, and then you ask it questions, and it figures out the answer. So it's very magical. The most popular logic programming language in the world is called Prolog. If we wanted to teach you a whole other language, we would use it. But Abelson and Sussman just did a very simplified logic programming system in Scheme. And that's what we're using. So to assert things, to tell it things, you say assert bang. This is a sort of a special form of the query language. Ryan likes pot stickers. Assertion added to database. So let's put in a few more. Okay, so here's our database of assertions. And now I can ask questions. A question is something that doesn't start assert bang. So I'm going to ask question mark who likes pot stickers. And in this system, a word that starts with question mark is a variable. And everything else is just text. And we get the answer, Jordy likes pot stickers. We get the answers, Jordy likes pot stickers, Brian likes pot stickers. Right? So this is the first thing to note about logic programming, is that you don't just get one answer. In this case, we got two answers. In some more complicated cases, there may be infinitely many answers. We don't have a system where that would happen yet, but it's theoretically possible for stuff we're going to learn in a bit. So I can say, Brian likes question mark what? By the way, I'm trying to use meaningful variable names here, but as always in programming, the query system doesn't care what name you use. It could just as well be X and Y, as well as the query system is concerned. And we get Brian likes pot stickers, which is a little interesting because Brian also likes ice cream. So why didn't it tell me that? And the answer is that this system works by pattern matching. So if I ask the question, Brian likes what? The way pattern matching works is for a list, you match the cars and you match the cooters. So recursively. So it's a potentially deep recursion. Although I don't think it will be for the queries that we're going to use, mostly. We'll see. And the way you match a non-pair is two things match if they're equal, and something that starts with question mark in the query basically matches anything. Okay? So this does not match Brian likes ice cream because, okay, Brian matches Brian, and then we have to look at the coulters, and we find likes matches likes, and then we look at those coulters, and we find question mark what matches ice, and that's fine. Then we look at these coulters. This one's the empty list, and this one's a pair, so they can't match. Those just don't work. So we could solve that problem by taking advantage of the notation that we have for improper lists. So I'm going to ask the question, Brian likes dot, question mark, what? And now I get both answers because this query is, instead of this, Brian likes dot what is this. So the coulter is question mark what. So Brian matches Brian, likes matches likes, and question mark what matches anything. Namely, it matches this entire list structure. Okay, questions about that so far? Who's with me? Awesome. Who's not with me? Nobody. Okay. That's great. That's not the way we usually solve the problem. Usually we solve the problem by taking ice cream and putting it in a list. So the assertion would always be Brian likes, and then one thing, a list of length 3. And in fact, what we really do is this. We say likes Brian pot stickers, likes Brian parenthesis ice cream. Oops. Ah. Uh-oh. Now I'm in trouble. Whoops. Oh, yeah. All right. Let's try again. Assert. Thanks. Brian. I'm afraid it actually took that assertion, though, but we'll see. There we go. So usually what we do is we take the name of a relationship, like likes, and that comes first. It's just a convention. As far as the query system is concerned, it treats every element of the query the same way, every sort of car of a list the same way, or coulter of a list, for that matter. But people find logic programs more readable if you put a relation first and the sort of arguments to the relation after that. So likes is a relation between two things, a person and a thing to like. So now I can say likes, well, likes Brian, what? Yeah, see, it did take it twice. Never mind that. Pretend that isn't there. Or pretend it's only there once. Although it does point up a problem, which is that if you have the same assertion in the database twice, it'll find it twice. I can say likes who, what? And then we also find out what Jordy likes. If I say likes XX, however, I get no answers. That only works likes Narcissus. Now I can ask the question likes XX, and I do find that. So the point of this is that once a variable has been matched in a query, any repeated occurrence of the same variable in the same query has to have the same value.